Okay, good day everyone. So today I'm going to present to you the model that I have chosen in the Gretl software, and this is called ordinary least square model. Okay, this is used for linear regression. So this time I'm going to use this model in doing simple linear regression. Okay, so what is this model all about? Okay, so ordinary least square model. So what is this? Okay, ordinary least squares regressions, or OLS, is a common technique for estimating coefficients of linear regression equations which describe the relationship between one or more independent variables and a dependent variable, okay, both for simple or multiple linear regression. So least square stands for the minimum squares error, or SSE. Okay. So maximum likelihood and generalized method of moments estimator are also alternative approaches to ordinary least squares. Okay. So this is ordinary least square. So this is use or a common technique for estimating a coefficient, okay, using the linear regression equations. Okay, so this is particularly about establishing a significant relationship between one or more independent variables and a certain dependent variables. Then after that, we can use that independent variables as regressors, okay, and forecasting or estimating or predicting future data based on the present data. Now, so when are we going to use ordinary least square model? Okay, so as what I have said a while ago, this model is used particularly in doing linear regression. So in linear regression, we're going to predict or forecast future data based on the present data. Okay, so ordinary least square model is used for linear regression, both for simple and multiple. Linear regression is used to predict outputs values for new samples. So this is done after establishing a significant relationship between at least two variables, independent and dependent variables. Okay, and here, basically, independent variables or variable will be considered as predictor or predictors, or regressor or regressors of the dependent variable. So this ordinary least square model is good to use in forecasting, predicting, or estimating future data sets based on the present data. So you say, for example, I'm going to conduct a research about students' problem-solving skills. So I'm going to construct a test about problem solving. Okay, I'm going to conduct that to the students who are taking a certain mathematics course. Say, for example, mathematics in the modern world. So I want to predict their grades in a certain course based on their achievement in a problem-solving test. So their scores in problem-solving tests will be considered as independent variable, and that will be used to predict their final grades in mathematics in the modern world course, which is considered as dependent variable. Okay, you can also use this ordinary least square model in estimating future data. Say, for example, number of enrollees for the upcoming school year. So you can use the present data, the present number of enrollees, as independent variable, and to predict the number of enrollees for the upcoming semesters or school years. And also in the business, you can also use this in forecasting or estimating future data. Say, for example, you want to forecast or you want to predict the number of productions of a certain product. Okay, so you can use your present values of number of productions or amount of sales, okay, as your independent variables to forecast the amount or the number of productions, okay, that you have to produce, okay, in order to meet the demands of the society. Okay, so actually there are a lot of ways we can use this ordinary least squares model, especially in forecasting or predicting or estimating future data sets based on the available present data. Okay, later part of this video, I'm going to show to you, or I'm going to simulate on how to use the ordinary least square model now in the Gretl software using my available data. Okay, so good day once again. Now, this time, allow me to show to you on how to use the ordinary list square in the Gretl software, especially in doing simple linear regression. Okay, so the first thing that we're going to do is we have to generate a data. So in my case, I have already generated a data in the Excel file. So what we're going to do here is we will convert this Excel file into a comma separated variable file extension, since this kind of file extension is the one that the Gretl software will recognize. So what we're going to do now is we're going to open this Excel file, and then later we were going to save this as comma separated variable. Okay, so in order for us to have a data, okay, a kind of data that will be recognized by the Gretl software. Okay, so this set of data is about the scores of the students in the problem solving test that I have conducted to them, and then their final grade in mathematics in the modern world. Okay, so I wanted to predict their final grade in Math using their scores in the problem solving test that I have conducted to them. Okay, so we'll click this the file tab and then save as. Then we will change the file extension into .csv. Okay, so we'll select this one, and then we're going to save this. Okay, so we have now a data in comma separated variable, okay, or comma separated values file. So we're going to open the Gretl software, and then we will click the file tab. Then after this, click the open data, then user file, and then we will locate the data that we had just generated a while ago. Okay, we'll continue. Okay, we'll change this file extension here into CSV. Okay, so there we have now the problem solving in mathematics .csv file. Open. We'll click the open, then we'll just ignore this one and this one. Okay, so this is just the summary of the data. We have 2 columns, 2 variables. So just close this one, and then we will now run the model. Okay, so our model is the ordinary least square model. So the first thing we're going to do is we'll just click the 2 variables, then click the model tab, then click the ordinary least squares, and then we have now this dialog box. So okay, so we will treat this Math final grade as the dependent variable. So we'll click this one, then this one, and then this one will be moved here, and then this problem solving scores as the regressor. So all the independent variables. So we'll just click this one, then click this arrow, then this one will be moved here, and then after that we will click OK. So this is the dialog box. So we have here different values. We have the coefficient, standard error, t-ratio, and then the p-value. Okay, so we have here, we can also see the r squared, which is 0.80. So it is almost 1. So this value 0.80 signifies, or it means that the model, the ordinary least square model, is performing well in doing the simple linear regression. So we also have the adjusted r squared. We also have approximately 0.8. Okay, so it means to say that our model, the ordinary least square model, is performing well in doing simple linear regression using the variables, the problem solving scores of the students, and their final grade in a certain mathematics course. Okay, so we can also have we can also predict the values, or we can also we can also have we can also show the predicted values. We'll just click this analysis and then display actual, fitted, or residual values. Okay, so this one okay, so this dialog box shows the ModMath final grade, then the fitted values, and then the residuals. Okay, so this is the actual ModMath final grade. Okay, so this is the dependent variable. So this is the fitted variable, or this is the forecasted values. Okay, so here the residual. Okay, so we're going to deduct 91 by 89.95, so we can have the residual is 1.05. So our aim is to reduce the residuals. Okay, so as you can see, the residuals are not that big, no, in all values, in all 90 values. Okay, so this one, yeah, we can also have this. We can also we can also generate the forecasted value. So just click the analysis, then click this forecast. Okay, we have 95% confidence interval. Then click OK. Okay, so the first dialog box shows to you the dependent variable. Okay, the variable that we want to predict. We wanted to predict, and then this is the prediction, or the fitted values. Okay, and then we have the standard error. Okay, and then we have the 95 confidence interval. So as you can see, for the first variable, 89, by the way, so our prediction is 89.95. So this predicted data, or predicted value, belongs to the 95 confidence interval. Okay, it means to say this 89.95 is fitted to the 95% confidence interval. We have 87.24 to 92.65. Okay, then the second value, for the second value, we have 89, and then the predicted value, we have 88.66. So we'll just see if this 88.63, by the way, belongs to the 95 confidence interval. Okay, so it clearly belongs to the range from 85.93 to 91.33. Okay, so we can observe that in all values, or in all 90 values. For the last one, we have the exact dependent value, we have 85, and in the predicted value, we have the 85.99. So it belongs so it belongs to the 95 confidence interval from 83.27 to 88.71. Okay, so we also have here the plot. Okay, so this blue line, blue line here, these two blue lines are the boundaries of the confidence, or 95 confidence interval. So these dots here, these are the values. Okay, and this green line at the center, it is the line of, or the point of estimate. Okay, so this is the blue line. Okay, this is the center. Okay, so this is the point estimate. So this is the line of the point estimate. So as you can see, majority of the values or the predicted values fall within the 95 confidence interval, since these dots fall between the two blue lines. Okay, so we can have here one value, so this value is considered as the outliers, so this one also and this one. Okay, but majority belong to the 95 confidence interval. Okay, we can see that in our r squared here, our r squared is almost 1. Okay, so it means to say that our two variables, we have the problem solving scores as independent variables and the mood math final grades as the dependent variables. They have strong or high relationship, or they are strongly correlated, or they are highly correlated. So there is a significant or strong significant relationship between the variables. And if the two variables have strong significant relationship with each other, then we can use the independent variable to predict the dependent variable. Okay, so here I can conclude that the problem solving scores of the students are good predictors of their mood math final grades. Okay, so this is how to use the ordinary least square model of the Gretl software in doing simple linear regression. Okay, thank you very much.